goodness, sorry. Okay, 7.5 is all about congruence. So that little symbol right there, that's just an equal sign with a squiggly on top. That is the symbol for congruence. So you'll be using that quite a bit today, actually. I'm going to try to show you the difference between congruence and equal, even though they look and sound like the same thing. So for equal, we're so used to seeing like this, x equals 5. So let's say that would be the answer to like this equation, right? We know we divide by 3 and we get x equals 5. With congruence, try to draw two angles that are the same. Label them A and B. This one, we would say angle A is congruent to angle B. So here's the difference. Why do we not use equal here? Why do we not use congruent here? We use equal here because x is 5. If I put 5 right in there for x, that makes the statement true. I mean, x and 5 are the same exact thing. Over here, though, these angles, sure, they look like they could both be, we'll say 30 degrees. They measure the same, but they are two different angles. This one's angle A, this one's angle B. So we can't put an equal sign here because they're not the same thing. They're two separate angles that happen to have the same measure. So a lot of the time in algebra, we'll use equal because that's just what we're dealing with, something that is the same thing. But with geometry, a lot of the times we use congruence because you're talking about two different shapes that have the same measures. So that's why this word comes into play instead of just saying equal. Okay, so here is the first question I want to ask you. What transformations keep the shape congruent? So whenever I say keep the shape congruent, I'm really saying it keeps the shape the same size. Okay, so if you think back to 7.1, what was the first thing we learned? Translations. And remember, we would just call that a slide. We'd just be sliding the shape over side to side, up and down. 7.2 was reflections. That one's we're just flipping the shape. Still stays the same size. And then 7.3, we did rotation, which that one we're just turning the shape. Okay, 7.4 was dilation. Now, dilation does not keep it the same size. It actually changes the size. So it would not be congruent after a dilation. So these are the three that we'll be using today. Okay, so for an example of what like your first 6 problems on your homework are going to be, is we'll just go over this. It'll load. These two shapes, would they be congruent? My answer is going to be yes, they are congruent. And then your second thing is what transformations were used. Well, if I look at this one, I would say this one was probably rotated to look like this. So your answer would be yes, congruent, it was rotated. Are these congruent? No, they're two completely different sizes. That's it. What about these? Nope. Again, two completely different sizes. These, yes, they are congruent. And what would I do to transform them? I would say this one would probably be a rotation, but then it'd be way up here, and then a translation. I'd have to slide it down to fit it here. Okay, or some people said rotation, and then a reflection, and then a translation. That's a little too complicated for me, though. Okay, so that's the first 6 on your homework. Pretty simple. And then the 3 on the back side of your homework are going to look more like this. Write the transformation on the shape then write congruence statements. Okay, so we're going to look at this shape first. So first I have to figure out what my transformation is. So how did I get this shape here all the way down here? I would say I just translated it, but it's facing a different direction. So we know something else has to happen here. So the first thing I say is, oh, it reflected. So if I reflect this point across this, I now have let's see, if I'm reflecting across the x-axis, the x stays the same, so it's still going to be -1, but my y changes, so now it's down here. So I would be down there, which means j would be down here, h would be right here, and k would be right here. Okay, so that's my reflection, which is great, but that's still not where this shape is. So I'm going to say reflection first. What do I have to do to get this shape right on top of that one? All I have to do is translate. So reflection and then translate would be my transformation that happened. Now you don't have to draw the shape on here. It's just helpful for me to draw it for this next part. So whenever you're writing congruent statements, you have to write it for the whole shape, all the angles, and all of the sides. So we'll do the whole shape first. These are four-sided, so we would say quadrilateral. I'm just going to shorten it to quad. And if we do this one first, let's just go IJHK. And that one is congruent to quadrilateral. Now, if I went IJHK, on this one I have to go the same direction. But remember, I is not X. I is actually corresponds with W. So we would start with W, and where do we go from there? VUX, because remember I flipped it. So that would be my whole shape statement. Then I need my angle statement. So this part, angle I, if I'm talking about angle I, that would be congruent to angle W. And you have to do that for every single angle. So angle J would be congruent to angle V. Angle H would be congruent to angle U. And angle, what letter is that, K? Would be congruent to angle X. Okay, another way to look at that is if you do this part correctly, then it's super helpful. You don't really even have to look at the picture again. I is the first letter, W is the first letter, J is the second letter, V is the second letter, H is the third, and then the last. You can always pair them up like that. And then you also have to do it by the sides. So if I look at like IJ, that bottom side there is going to be congruent to WV. Then JH would be congruent to VU. And then HK would be congruent to UX. Once again, HK, UX, kind of just following that there as well. And then IK would be congruent to WX. Okay, so lots of writing, but it shouldn't be super difficult writing. You're just kind of piecing together what matches. Just kind of like a advanced match game. Oh. Okay, so let's do one more. This one's a little bit easier. So example 2. I'm not going to write all the instructions out. Just put our picture there. Okay, so first we have to say what transformation happened. Well, how did it get facing this direction to facing that direction? All that happened here was a reflection. So that makes it a little easier on us. Okay, so I'm going to set you up with the whole shape. And on your homework, you don't have to label these. I'm just trying to do that so you don't forget all 3 steps. Quad, let's go with this one first. So MNOP, just like the alphabet, I went down and around. quad. Now M has one little arc mark right there. So that tells me that M is equal to the one that has 1 on this side. So A. Then we went in, so then we're going to go B, went down, so O and K, and then S. Okay, so I want you to try to do the angles on your own now. Try to write them all down. So really, pause this, write all your angles down. Don't forget that you can look at your statement that you just made to help you too if the shapes confuse you. Sorry, I'm writing them down too. Okay, so this should be your angles. Now write down your sides. Pause it, write down your sides. Don't forget the line over your sides. That's pretty important. Okay, that is your sides. Okay, that is the lesson on your homework. You have the first page where let me just grab this one real quick. You have this first page here where you were just telling me yes or no, it's congruent. If it is congruent, explain using your transformations how. And then on this back side, you just have 3. You're still telling me what transformations, but you have to do all the congruency statements. Okay, that is it.